Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra class. Today we are going to continue with factoring polynomials. And today we're going to talk about factoring special cases. So far, what have we learned? We've learned a lot. We've learned how to factor any polynomial by taking out their GCFs, right? For example, if I have 12x cubed minus 4x squared, okay, that's going to give me what? I'm going to factor out my GCF of a 4x squared. I'm going to put that outside of the parentheses. I'm going to divide every single term by a 4x squared, and I'm going to have the leftovers inside of the parentheses, so this would be 3x minus 1. Okay, that's factoring by using the GCF, the greatest common factor. We've also learned how to factor trinomials in two different forms. The first form, when it's x squared plus bx plus c, the a, which is in front of the x squared here, is invisible. It's a 1. For example, let's say I give you x squared minus, 6x plus 8. Well, the way we learn this is our setup. We have an x and an x. Why? Because it's the square root of the first term. And then you ask yourself, what times what is the c value, which is 8. When added together is the b value, negative 6. So that'd be a negative 2 and a negative 4. And that would be your answer, x minus 2 times x minus 4. If we're given a trinomial with an a other than 1, when a is not 1, it's anything else but 1, a 5 or a negative 5 or a 10 or a 12 or a 6, anything other than 1, we have a different type of procedure. It's very similar. For example, let's say we have 6x squared minus x minus 12, okay? In this particular case, my setup, we have the ax and the ax. It's the square root of the variable, but the a stays the same on both. You multiply a times c. 6 times negative 12 is negative 72. That is my new c value. What times what is negative 72, but when added together is negative 1. That's going to be a negative 9 and a positive 8. Then I imaginary factor. I imaginary factor because I'm taking out the GCF, but I am not putting it in front like I did here. It's imaginary. This is a trick. It goes bye-bye. So I'm left with 2x minus 3 times 3x plus 4. And that, my friends, would be my answer. So far we've learned a lot. Last thing that we've learned, we'll do it in green, is factoring by grouping. This is where you create a common binomial and you factor out that common binomial, and the leftover factors are pulled out as the second binomial. For example, let's say I have 6x squared minus 3x plus 4 minus 8x. Well, I first look to see if there's a GCF. There is no GCF here, so I group them. Literally, I group them. That's a plus. I factor out of here a 3x, so I'm left with 3x times 2x minus 1. Now, from the second binomial, I want to make it a 2x minus 1. What must I divide from here to make that negative 8x turn into a positive 2x? A negative 4. Very good. So I pull out a negative 4, and I'm left now with negative 1 plus 2x. Do you guys see how that works out there? Now, from here, I'm sorry that hold on, let me see if I could do this over here. There we go. Sorry about that, but I just want to continue the flow. Now I have my two like binomials. 2x minus 1, 2x minus 1. So I take out that common binomial, and I create another binomial with the leftover negative 4 and 3x. So that's grouping. Okay? So that is everything that we've done. We have done a lot of powerful math. This is essential, crucial, necessary for next chapter, which is solving quadratic functions. If you can't do this, it's going to be very difficult. So please make sure you understand the processes. So that's where we've been, my friends. Today we'll learn how to factor special case polynomials, which include perfect squares and the difference of squares. Let's examine the table below. Perfect squares. Perfect squares are in the form of a squared plus 2ab. Give me 1 second. Let me clear something up here. Okay, now, much better. Perfect squares are of the following nature always. When you see the first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the square root of the first term times the square root of the second term, you have what's called a perfect square trinomial. Do you guys remember when we learned how to multiply a plus b squared? If you remember, a plus b squared, it would be the first term squared plus 2 times the first times the second plus the second times squared. Do you guys remember when I taught you that I said we're going to see this again when factoring? We're going to reverse it. Well, for those of you who learned this, this is going to be very simple for you. For those of you who did not learn this, no worries. You can either learn it now or use the normal factoring methods that I have taught you. Let me show you what I mean. For x squared plus 6x plus 9, this is how I do this. Is x squared a perfect square? What is the square root of x squared? Is 9 a perfect square? What is the square root of 9? What is 2 times x times 3? What is 2 times x times 3? So this works. So this is an x plus 3 squared, and I'm done. Now, let's say you don't want to go through the trouble of learning this, which is not what I recommend. But it happens. Or what if you forget? You're a human being. No worries. Do it the normal way. X and x. What times what is 9, but when added together is 6? Positive 3 and positive 3. Isn't x plus 3 times x plus 3 x plus 3 squared? I don't think that's much faster or quicker. Because, for example, here, for this example, my answer is x minus 2. I think that's faster and quicker. How did you get that, Mr. Morrill? Very simply. I do this in my head. Is that a perfect square? What's the square root of that? Is that a perfect square? What's the square root of that? Okay. What's x times 2 times 2? 4x, but it's a negative, so it's x minus 2 squared. Are you guys seeing the process here? Now, you don't want to learn it? Okay. You don't like it? Okay. You're scared you may forget it? Okay. Do it the long way. X, x. What times what is positive 4, but when added together is negative 4? Negative 2, negative 2. Doesn't that equal x minus 2 squared? So it doesn't matter. However, it's good to know them. Why? Why would it be good, Mr. Moore? You're showing us that we can do it either way. I understand that. What if I give you this, my friends? And this can very well happen. Easily. Let's say I told you factor 16x squared. Let's go, bless you. Okay. These are some very large numbers, aren't they? Can't you do the cubic method, Mr. Moore? Sure. You could go 16x, 16x, but now you're going to have to multiply 16 times 49, find that product, and then figure out what times what is that product, but when added together is 56, bless you. Do you think that's going to be a fun journey? That's why I teach you, and the book teaches you, and algebra teaches you, the perfect square. What's the rhythm here? Is the first term a perfect square? What is it? 4x. The square root of 4x squared is 4x. Come on, Moral. Just 4x. Square root of that is 4x. Is 49 a perfect square? That's 7. What's 4 times 7? No, 4 times 7. 28 times 2. Does it work? 4x plus 7 squared, you're done. Do you guys see this? If this number is not a perfect square, or that's not a perfect square, then this is not a perfect square binomial. It's that easy. Does that mean you can't factor it? No, that means you have to go to the cubic method. Okay? Does that make sense, guys? Now, they're not always going to be large numbers. Sometimes they'll be nice numbers, but you still need to know it. For example, let's say I go 4x squared plus 9 minus 24x. Actually, wait. That's going to be, sorry. Is 4x squared a perfect square? What is it? Square root of 4x squared is 2x. Is 9 a perfect square? What is it? Square root of 9 is 3. It's a negative, right? Okay. What's 2 times 3 times 2x? 12x, so I put a minus. Why? Because there's a minus. Bing, bang, boom, I'm done. Does that make sense, guys? Mr. Moore, I don't like that method. Okay. Then you have to go the long way. This would be 4x, 4x. Good man. New C is 36. What times what is 36 when I add together is negative 12? Huh? No, negative 9 plus 4 is not going to give me negative 12. Negative 6 and negative 6. Imaginary factor, imaginary factor. I got 2x minus 3 times 2x minus 3, which equals 2x minus 3 squared. I am highly recommending that you learn the formula, though. It's going to make your life so much easier. For example, what if I give you, let's see, let's do 64x squared, let's do plus 121, so that's, right, plus 176x. Those are some huge numbers. I'm not saying that you cannot do it, but it's going to be virtually impossible to do this the cubic method. Is this a perfect square? What's the square root of this? 8x. Is that a perfect square? What's the square root of that? 11. What's 8 times 11? 88. Times 2? 176. So you know it's a perfect square. You put a plus because that's a plus. And you're done, my friends. Does that make sense, my brothers? And I hope out there in the internet world, this makes sense as well. So for this one, super duper important that you do learn it, but it's not mandatory. It's not. I'm not going to lie to you. But it's really, 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 really important. However, here, guys, I'm sorry. There is no choice here. You have to memorize difference of squares. Difference of squares is a squared minus b squared factors out into a plus b times a minus b. Again, do you guys remember when I taught you a plus b times a minus b? Remember there was a trick here. We said it's the first term squared minus the second term squared. Okay? Well, if you remember that, you can reverse this very easily. When I have two values that are perfect squares that are being subtracted from each other, okay, the way this is going to work is it's the square root of the first term, right, minus the square root of the second term times the square root of the first term plus the square root of the second term. That's how you factor this. It's that easy. For example, x squared minus 16. What is the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the first term? Done. Done, done, done. What do you mean I leave it like that? That is the answer. It is factored. A squared minus b squared equals a plus b times a minus b. First term square root plus the second term square root times the square root of the first term minus the square root of the second term. If I go ahead and multiply this again, I go back to x squared minus 16. No, I did not say it's the square root and you just put a plus. I said it's the square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. Thank you for asking, sir. Okay? Now, what if I gave you, I don't know, 16x squared minus 81? Square root of the first term is plus the square root of the second term times square root of the first term minus square root of the second term. Done. Literally. Sir. Does not matter what order. If you want to put the 4x minus 9 first, that's fine. Sir. No, there is no imaginary factor here. The only time, guys, we went over this. The only time imaginary factor works is for the Cuban method. And that's it. No, I'm not going to say if this was or if that was. I'm not trying to be rude. There's no imaginary factoring. Okay, what are you talking about now? No, no. You would factor out a GCF then. That's not what you said. Okay. What my boy is saying is this. Let's say I had 32x squared minus, let's say 18x. That's fine. X to the 8th. Let's do it that way. Okay. Can I factor anything out here, first of all? Can I factor anything out here? Actually, wait. Don't make that an 8. Make that actually, let's make this a, no, I don't want, yeah, let's make it a 2. Yes. Okay, what can I factor out of these guys? A 6? No. Come on, guys, let's think. What can we factor out of both of these, please? They're both even numbers. A 2x squared. Thank you. And then I'm left with 16x squared minus 9, correct? So this is going to give me 2x squared times 4x plus 3 times 4x minus 3. Does that answer your question now, my brother? If you can take out a GCF, you take out a GCF first, and then you factor the rest. Yes, you were. You were asking me, you said, what if it was a 81x squared minus 9? And that's exactly what I'm telling you. You have to factor out a GCF. So you would factor out a GCF, and that would be 9x squared minus 1. This would factor out to be 9 times 3x plus 1 times 3x minus 1. So I did answer your question, didn't I? Thank you very much, sir. You just got to pay attention to me, sir. I always will answer your questions. So if you have to, like I've said many times before already, before this lecture, you must always factor out a GCF first. You must always factor out a GCF first, if possible. Okay? Does this make sense, gentlemen? Thank you very much, gentlemen. Okay. Now, sum of squares. I just got to show you because it's prime. And I want you to understand that it is prime. There is no way to factor this. Please do not put, oh, that's x squared plus 5, x plus 5, x minus 5. That is wrong. It is prime. When you have the sum of two perfect squares, it is prime. It is not factorable. If I can possibly factor out a GCF, do I do that? Yes, but after that, I can't do anything else. In that case, it would not be prime though, right? If I told you guys, if I said to you, 2x squared plus 2x squared plus 32, let's say. I can factor out a 2, making this an x squared plus 16, but that's it, I'm done. I do not put prime in that case. Why do I not put prime? Because I factored out a GCF. If I factor out anything, it's not prime. But from here, can I go any further? No. But if I give you this, that is straight up prime because there's no GCF and you cannot factor it. Does that make sense, my friends? Okay, thank you so much. Let's continue. Let's practice, guys. Practice, practice, practice. Now, I am not going to do these the long way. The whole point of today is to learn the easy way. I will verbally tell you what I'm saying. I will verbally tell you what I'm doing, though. Is this a perfect square? Is that a perfect square? Okay, square root of the first is x. Square root of 16 is, what is x times 4 times 2? 8x. So does that work? It's a perfect square trinomial. Number 2. 2 is here. Okay, is that a perfect square? Is that a perfect square? Can I factor out a GCF? No. Okay, square root of the first plus square root of the second. Well, that's an ugly 8. Times square root of the first minus square root of the second. Does that make sense? Promise? Okay. Number 3. Now we get into some larger numbers. Is that a perfect square? 6x, good. Is that a perfect square? Square root of that is 5. What's 6 times 5? Times 2? So it's a minus here, squared. Done. Are you guys understanding the rhythm here, my friends? Okay, 18y squared minus 98. Is 18 a perfect square? Is 98 a perfect square? Do they have a GCF, though, that I can factor out? Okay, what do we got? 3? No. Okay, 4, no as well. It's an even number, so it's 2. Very good. So I've got 9y squared minus 49. Now, wait a second. Is that a perfect square?
Yes.
Is that a perfect square?
Yes.
Are they being subtracted?
Yes.
So it's going to be square root of the first plus, good, plus square root of the second times square root of the first minus square root of second. Does that make sense, guys? You understand where I'm coming from here? Okay. Let's move on. We're good? May I move on? Okay. Is that a perfect square? And that square root of that is that a perfect square? Square root of that is, what's 10 times x times 2? 20, but there's a negative, so put a negative here. I got x minus 10 squared. That makes sense, boys? Okay. 2x squared minus 2, are those perfect squares? No, they're not. But can I factor out a GCF? Yes, I can factor out a 2. When I factor out a 2, I get x squared minus 1. Is x squared a perfect square? Is 1 a perfect square?
No.
Yes, 1 times 1 is 1. Yes, it is a perfect square. So I've got 2 times x plus 1 times x minus 1. Very good. Square root of the first plus square root of the second times square root of the first minus square root of the second. Number 7, 4x squared plus 81.
2x.
Okay, right? 2x plus 9, right? Right? 2x minus 9, right? Wrong. Guys, it's prime. There is no sum of squares. I led you down that path and you guys just followed me. Come on. There, I definitely tricked you. That was not a mistake on my part. I knew you were doing it wrong. Okay. 4x squared plus 24x plus 36. Before I do anything, because yes, I know these are both perfect squares, right? But can I factor out a GCF? Yes. Please, guys and ladies out there in the internet world, anytime you're factoring, always see if you can factor out a GCF. And in this case, you can. 4 is my GCF, so I'm going to be left with x squared plus 6x plus 9. Okay, is that a perfect square?
Yes.
What is it?
X.
Yes. Is that a perfect square?
No.
9? Yes, it is. It's 3. What's x times 3 times 2? 6x. So this is a perfect square trinomial. Done. Does this make sense, my friends? Okay, this is going to be the last thing that we really learn. Tomorrow, we're just going to practice when to use what. But I got to make sure you understand this. You're good with this. Okay, let's continue. Okay, number 9. You tell me now. X plus 11, x minus 11. How did this happen? Square root of the first plus square root of the second times square root of the first plus square root of the second. Done. Number 10, what you got? Very good. Square root of the first plus square root of the second times square root of the first minus square root of the second. 15 times 15 is 25. Very good. Okay, number 11. Is that a perfect square? Is that a perfect square? Okay, what's the square root of 4x squared? Yes. What's square root of 81? Yes. What's 2 times 9?
18 times 2 is 36.
Times 2 is 36. So this is a perfect square trinomial. Not 4x, it's 2x plus 9. Because the square root of 4x squared is 2x, my man. Thank you, sir, for caring. Okay, number 12. Is that a perfect square? Is that a perfect square? Okay, so I have 4x and a 3. What's 4 times 3? Times 2? So this is a perfect square trinomial. Okay, is 27 a perfect square? Is 12 a perfect square? Do they have a common factor, though? Yes. So I pull a 3 out, and I've got 9x squared minus 4. Now, is this a difference of squares? Yes, so what's my answer? Square root of the first plus square root of the second times square root of the first minus square root of the second. Does that make sense? Okay, next. 64, is that a perfect square? 12, is that a perfect square? Can I factor out a GCF? What's GCF? 4, very good. So I've got a 16x squared minus 3. Oh, wait a second. Is that a difference of squares? No. So we're done. All I could do there is take out a 4. There was no difference of squares there. Does everyone see why this happened? Who said no? Okay, why? What don't you see? Is that a perfect square? Is that a perfect square? So I can't have a difference of squares. In order to have a difference of squares, it's a difference of 2 perfect squares. This is as factored as you can go. Yes, sir. No, thank you, sir, for your honesty. I appreciate that. Thank you very much. Does anyone else not understand that? So I can help you. Okay. Next. Whoa, look at this crazy number. No big deal. That is a perfect square.
25.
It's very good. It's actually 25x squared, right? Plus 4. And then 25x squared minus 4. Now, we're done, right? No. Guys, is that a perfect square?
Yes.
Is that a perfect square?
Yes.
So check it out.
5, 2.
It's 25x squared plus 4, because I cannot factor out a sum of squares, times 5x plus 2 times 5x minus 2, because that's this difference of square factored out. Does everyone see that? You promised me. What happened? What do you mean you don't get it? We did the same exact thing. Square root of the first. We did the same exact thing. Well, if you got the first part, you'll get the second part. Square root of the first plus square root of the second times square root of the first minus square root of the second. This is it. It is unfactorable. So that is 25x squared plus 4. But this is a difference of squares. Square root of 25x squared is 5x plus square root of 4 is 2 times square root of the first term minus square root of the second term. That is my final answer. Thank you so much for your honesty. Thank you very much. Okay, next, 16. Is 7x squared a perfect square? Okay, is 112 a perfect square? No. Can I factor a GCF? 7, very good. Giving me an x squared minus 8x plus 16? 16. Now, is my first term a perfect square? What's the square root of x squared? Is my second term a perfect, third term a perfect square? What's square root of 16? Okay. What's 4 times x times 2? 8x, but there's a negative, so what do? Put a negative and square it. Ding dong, the witch is gone. Does that make sense, my friends? Fantastic. Thank you so much, and I hope you learned a lot. Have a great